So in this video, we'll quickly look at how logistics or decision tree-based classification model can be used to score a given demographic. In this case, specifically, we are looking at the credit scoring. So typically, we would have a database. This is from a German credit data, which is available on online.psc.edu. This is a psc.edu website, which has made this data available. So typically, you would consider a number of demographic as well as financial transaction-based information for evaluating any given potential customer as to whether the person is worthy of providing credit or not. So you can see the variables could be existing account balance and duration of credit, payment status, purpose for which the credit is required, credit amount, and so on. So there could be a number of variables, some demographic variables like gender, marital status, age, and so on. And the response variable would be the decision, which is creditability. One means the person is worthy of credit, and zero means the person is unworthy. So a good way to model this, since we have a binary output and a combination of continuous as well as a class variables for independent set of variables, we would use a logistics regression model, and we could also use a decision tree or forestry-based classification model. So we are not using a regression model, but we are using a classification model, considering the data types and the nature of data. So this can be done quickly through first doing. So we have to do a data partition. So we'll have to divide this into training and test data. So we'll quickly do a training example. So we can do that using a certain predefined partition. I've taken 50%. And similarly, we can choose other percentages. And what we would have chosen for train, we will not use for testing for obvious reasons. And once I do that, I'll quickly do modeling based on a number of variables. This is through GNM command. And then I can quickly look at the summary of the data, which is here. So I can see which variables are relevant. I can quickly look at the p-value for their significance. And based on that, I can choose a smaller set of variables. So with that, I can have a relook at how my model looks like. And I can see that most of these, in fact, every variable, including the intercept, is significant, considering the 95% confidence levels. So once we have that, we will use this for prediction. And then I have to do a small conversion because the output is in terms of probabilities. So I have to convert this back into 1 and 0. So that's a custom function. And I can use that to get back my zeros and ones, or whether the person is worthy or unworthy of credit, and then I will set it back into my test database. And for further evaluation, I will quickly form a data frame and compare the original versus the predicted value sets. And then I can calculate a range of evaluation parameters like precision, recall, accuracy, specificity, sensitivity, misclassification, and so on. So let me quickly do that manually here, because if you understand each of these performance measures, then you can code it yourself. And then you can see the precision, similarly you can see recall, and range of other values. And if you don't want to do this by hand, then you can do through ROCR package, where I can quickly create a new data frame and set the prediction variables. And then finally, I could choose from a range of values. So this is true positive rate versus false positive rate, for example, and then I will plot this. So for plotting, I will just use the performance object, and then I can see a plot. For instance, here I can see how my model achieves the right classification while, and then I have to also evaluate, how it is able to avoid the false positive classification. So I would see that probably the mean would be somewhere around this point, which is so between 0.6 and 0.8. So roughly between 0.7, 0.75. That's the approximate knee level, and I can quickly just use the AV line command here to plot. So AB line, and then H is equal to 0.8, and T is equal to 2. And that's roughly where I would look at the knee line, and that's about 0.4. So there is a 40% false positive classification rate. So that's something that we have to take into account. And once I do that, there is another way to achieve the same through confusion matrix, for which I'll have to install a certain package like E1071. And once I do that, I can quickly see the values which are computed ready-made for you. So that's another way to look at it.